MS Ramaiah University of Applied Sciences.
Hi students, the aim of the experiment is to determine the particle size distribution of the given coarse-grained sample as per IS 2720 Part 4. Soil samples are classified as coarse-grained soils if the particles are larger than 75 micron size. More than 50% of the total soil mass should be larger than 75 micron for the sample to be classified as coarse-grained soils. Gravels and sands may be either uniformly graded or well graded depending upon the value of coefficient of curvature and uniformity coefficient. Coarse-grained soils are classified by Sieve analysis. Soil gradation is the distribution of grain size present in a soil sample and is expressed as a percentage of the total dry weight. Grain size analysis is widely used in classification of soils. The data obtained from grain size distribution curves is used in various field applications like design of filters for earth dams and to determine the suitability of the soil for different types of constructions. The relative proportions of different grain sizes which make up a given soil mass can be determined from this test. Experimental setup. Weighing balance sensitive up to plus or minus 0.01 grams. IS sieves of sizes ranging from 4.75 mm to 75 microns. Mechanical sieve shaker. Experimental procedure. Take a known quantity of soil sample which is passing through 4.75 mm sieve and retained on 75 micron IS sieve and weigh it. Arrange the series of sieves with the sieve size decreasing from top to bottom. Keep the weighed soil sample on the 4.75 mm sieve and cover it. Pan should be placed below the 75 micron sieve. Keep the sieves on the mechanical sieve shaker for about 10 minutes. Weigh the material retained on each sieve. Percentage of soil retained on each sieve is calculated on the basis of the total weight of the soil sample taken. Calculate the percentage passing through each of the sieves. Draw the grain size curve for the given soil in the semi-logarithmic graph. The data collection and tabulation is as shown in the table. Weight of the soil for sieve analysis W and weight of the soil collected in pan WF are calculated. The plot of percentage passing through sieve versus sieve sizes obtained is as shown in the figure. Uniformity coefficient Cu is equal to D60 by D10 and coefficient of curvature Cc is equal to D30 square by D60 into D10, where D60 is the diameter corresponding to 60% finer in the particle size distribution curve, D30 is the diameter corresponding to 30% finer in the particle size distribution curve, and D10 is the diameter corresponding to 10% finer in the particle size distribution curve. The results obtained are coefficient of gradation Cu is equal to 3.8, coefficient of curvature Cc is equal to 1.05.
Dear students, today we are going to perform sieve analysis. The aim of this experiment is to analyze the particle size distribution of a given soil sample. For conducting this experiment, we require a mechanical sieve shaker which is used to shake the sieves containing the soil sample so that the soil will get sieved through the various sieves. This mechanical sieve shaker is generally set for 10 minutes so that the samples will be shaken for 10 minutes, and this dial gauge shows how much minutes it is being set, and it is operated by a switch over here. A set of sieves. This is the sieve set. The sieve set consists of a lid and a number of sieves arranged in their decreasing order of size. Bottom we are keeping a pan to collect the soil sample which is sieved through the last size sieve set. Now the sieve set consists of a 4.75 mm sieve, 2.36 mm sieve, 1.16 mm, 1 mm, 600 microns, 300 microns, 150 microns, 90 microns and 75 microns. This sieve, this 4.75 sieve indicates that the size of the holes in this is of 4.75 mm. Now the next sieve set is of 2.36. Now you can see the difference between the sizes of the sieves. This 2.36 sieve is smaller than 4.75 mm sieve, and those soil samples whose size is less than 4.75 mm will pass through this and move to this 2.36. If the soil sample is smaller than this 2.36, it will move on to the next sieve and the process continues until the last sieve is passed. A weighing balance which is used to weigh the sample, and the accuracy of the balance should be approximately plus or minus 0.01 grams, and a pan for collecting the soil sample. This is a pan which is taken to collect the soil sample. To start the experiment, first we take the pan and keep it on the weighing balance and tare the weight to 0. Now the empty weight is 0.241. I'll tare it to 0. Now I am going to place the soil sample in this. The soil sample which we take is about 1 kg. Now, place the sample in the mechanical sieve shaker. Adjust it to the center and then fix it using the screws. Make sure that the lid is tightly inserted into the sieve. After fixing the screws, set the dial to 10. This indicates that the shaking is going to happen for 10 minutes. Now, after setting the time, switch on the motor. Once 10 minutes is over, just switch off the machine and release the screws. Remove the sieves from the shaker. Once the sieving is over, weigh the soil sample retained in each of the sieves. For example, I am taking the first sieve, 4.75 mm. I am using this weighing balance for weighing the machine. I have tared the weight of the pan which I am using to measure it. Transfer all the soil sample into the pan and weigh it. Note down the weight. Similarly, once it is over, remove it. Take the next sieve size and weigh the soil retained in that sieve. Note down the weight of the soil retained in that sieve and take it. Similarly, Weigh the soil sample retained in each of the sieves and note down the readings. Finally, measure the amount of soil which is retained in the pan also. This indicates that these many soil particles is finer than 75 micron. Once the samples are weighed in all the sieves, it has to be noted down and calculations should be done for finding out the percentage finer soil samples. That complete the experiment.
At MSR UAS, we spark your imagination unlike any other.